Hello, everyone. Welcome to another Healthgivity podcast. Today we have Dr. Chris Rhodes with us, and we are going to talk about an amazing topic with recently, actually, a lot of people are talking about that, but we're going to talk about a breakthrough that now we can actually biohack our body with fasting. So today we are going to talk a lot about fasting. And of course, I have some questions. And recently, actually, this is one of the most controversial, some studies out about fasting.
Mhm.
So we want to talk about that also. So welcome, Chris. Thank you so much for being with us today.
Yeah, absolutely. Thank you so much for having me. It's great to be here.
Thank you so much. So, everyone has a story when we talk about longevity, when you became interested actually to enter to this field and how everything started. So, I would like to hear from yourself that what was the first point that you became interested in this, and of course later about fasting.
Yeah, absolutely. I mean, my journey into longevity kind of parlays directly into my journey into fasting. But I got my BS in biochemistry from Loyola Marymount University down in LA. But when I got out, like a lot of college kids, I really didn't know what I wanted to do. So took a immunology fellowship at Stanford. Just kind of started pouring through all the research I could get my hands on, all the seminars I could go to. And eventually, at the time, like the longevity research was kind of just starting to be popularized. There were some really interesting papers that were just coming out about it. And I kind of just fell in love with the science of it all because it used to be something that was very, mythological, right? Just like a legendary Ponce de Leon and the Fountain of Youth kind of thing, but was now this really active area of scientific research. And the longevity field to me was so interesting because it was this one thing that could kind of help with everything, right? Age is the biggest risk factor of all disease. When you look at the statistical data, by and large, young people don't generally get sick, right? It's really as aging progresses that you see all this disease pop up. And that's, deterioration of the system over time, things like chronic, inflammation, stem cell senescence, all that fun stuff. But if you can solve longevity, you can not only really expand, human lifespan on an individual level, but also like tackle all of these diseases at the same time, and then lead to kind of like these this point in society that we've never really been to before. For a lot of our time on Earth, a human generation or a human lifespan has only really been able to last for 100 years. So that's how much collective memory we can really store from like one person to another. Whereas if you can extend that out to 120, 150 years, at the really big levels, then you can kind of create this different kind of society than we've ever really had before, with people who were able to say like, yeah, I was alive in 1950 and now it's 2070 and I'm still going strong, and I have that memory of seeing society progress and where it's come from and where it's going, and that collective intelligence and knowledge. If we had gotten another 50 years of Einstein, right? What else could have happened? So that was really what excited me about longevity. And really, when you're in longevity, eventually you come across fasting, because fasting is one of the only ways that we know of to reliably extend lifespan. And that's really what lit me up about fasting, is that it's this way that we know to extend lifespan. And it does that without actually adding anything into the system, right? So it's not this superfood or this wonder drug, but somehow fasting is activating this, dormant longevity bio program that we already have inside of us, but just isn't ordinarily turned on. And that's really what got me into fasting, was trying to figure out, all right, what's going on in the human body or in, model organisms that could be like causing this big shift in our metabolism and our biological functionality that basically extends our longevity. And is there a way that we can recreate it?
Yeah, amazing. So, before, let's say, like 30, 40 years ago, we didn't know much about, the mechanism of longevity, and we couldn't actually do anything about it. So that's why I think still some people that I talk to them, they don't believe such a things, but, exist. Like you take a pill and it works just like the fasting and even maybe much better. They think it's like a sci-fi, right? Because for many years we've talked about before longevity, I mean, maybe in 2000 or something, we called it anti-aging, right? And then after that, now we call it longevity. So these years, actually, we have had a lot of breakthroughs, but still, I think a lot of people don't know about it. That's why one thing that we do in our project is to bring more and more people and simplify it for them. But before we go actually deep into fasting, I want you to tell us a little bit about the let's say the history of fasting, because I really love evolution, and I think we cannot explain anything in biology without having a look at the evolution. So we have to go back hundreds, thousands, or maybe millions of years ago and see that what was happening with us, with our body, our lifestyle. So can you tell me from that perspective that why fasting is beneficial for our body when we are looking at, let's say, the whole process in terms of evolution, how um, fasting can really help us to have a healthier body and live longer.
Yeah, absolutely. So yeah, the evolutionary origins of fasting and caloric restriction and why it has these beneficial effects on biology are really interesting. And it does come down to kind of um, your body's biological methodology for trying to keep you alive as long as possible so that you can procreate. So essentially, if you think about the normal environment, right? There's plenty of food around, you're in a fed state. That is giving your body an evolutionary signal that the environment that you're in would be really good to raise progeny in, right? So if you have the next generation, there's plenty of resources around that can help them survive. So in that state, your body is going to focus more on trying to get you to that stage of procreation because now's the opportune moment. So it's going to really care less about your immediate health or your like prolonged longevity so much as it's going to focus on reproductive functions, making sure that you can have actual children and propagate the species. So it's going to basically run dirty. It's going to be producing a lot of proteins that it maybe doesn't need. It's not going to be correcting as much damage that's happening to the body because you have all these nutrients around. If something goes wrong, your body can always just make a new cell. It's fine. There's plenty of resources. In a fasting state, it's really the opposite of that. When there's not a lot of nutrients around, that's a signal from an evolutionary perspective that the environment that you're in would be a really bad place to, have children because most likely there's not going to be enough resources around to keep them alive. So instead of focusing on the next generation, fasting is going to give your body an evolutionary signal to really focus on prolonging the health and longevity of the current generation, which is, your body and your cells. And that's so that you can find eventually in the future an environment that is nutrient rich where you can propagate the species, but your body needs to keep you alive until then. So what you see in fasting is when there's this big drop in nutrients, your cells all of a sudden have to run clean, right? They have to maximize their metabolic efficiency, turn on these processes like autophagy, where you're breaking down dysfunctional proteins and organelles, turning them into new functional ones to conserve energy and resources. You have to, alter mitochondrial function to, again, be more energy efficient and produce less damage overall. Turn on stress resistance genes to make sure that you're protecting your cells because, again, if something goes wrong when you're fasting, you're not going to have the nutrients to build a new cell. So you have to put all of your energy and effort into making sure that the current cells are protected and healthy. And that's essentially what longevity is in the long term, like the protection and maintenance of the current generation and your current cells. So that's kind of how, from an evolutionary perspective, fasting is more or less designed as this, again, bio program for longevity.
Right. Amazing. So, kind of, let's say fasting puts our body in the survival mode, right? So that it's much important to survive now and ourselves than, let's say, next generation. So, if imagine that, let's say, fasting is a process, and we know that we have different kinds and methods of fasting, and about the period of time, we can, let's say, from 12 hours, 18, 24, 36, and then 48, up to 72, and even more than that. But let's imagine 36 hours of fast. if we want to say that what is the most important thing that happens during this 36 that which help us, our body, to kind of, let's say, rejuvenate its cells or has that beneficial effect for longevity, what is that one that maybe a mechanism or something that happens within this 36? Because later I want to compare it with the Mimeo, right? We want to
Yeah,
see that
sure.
what happens naturally in the body and what happens when we are just, let's say, taking the Mimeo. So can you tell us that what is the most important thing that happens during the 36 hours of fasting?
Yeah, that's a great question. And I'm not actually sure if there's one answer to it.
Mhm. Right.
Since fasting is this very holistic process that's really changing around systemic biological function, you have a lot of things that are in flux that are different between the baseline state and a fasted state. And that's really going to be about changing around your metabolic functionality, your metabolic efficiency, like we were talking about before. I mean, I think a big one is definitely autophagy, this whole turning on of the cellular recycling processes, that breakdown of dysfunctional organelles, mitochondria, and proteins, so that we can create new functional ones and like really dial in more effective cellular function, the upregulation of the cellular response genes that increase in metabolic efficiency so that you're not producing a ton of waste. There's also a lot of very potent anti-inflammatory effects that happen during fasting. And that's because, again, that's a signal to your immune system to kind of dial it back to a certain degree. In a normal fed state, when your immune system has all the nutrients it needs to be able to create inflammation or, detect a lot of pathogens or like deleterious cells in the system, it's going to be more reactive to those stimuli versus a fasting state where it doesn't have as much nutrients. It's not going to be quite as reactive. So that can be very good for autoimmune responses in terms of kind of like dialing back the autoreactivity. So there's a lot of things that are happening in fasting that are very important in like even beyond the ones that I just kind of listed here. But really, I would say from the really high level, I would say that shift in metabolic efficiency, kind of going from glucose metabolism to fat metabolism and prioritizing some of these more or what we would call like pro-longevity or even catabolic pathways like AMPK, like the NAD/SERT pathways, and down-regulating some of these like pro-growth, pro-aging pathways like mTOR, for example.
I am very much interested in actually sleep. I know that, and I believe that sleep is the first and the most important part of the longevity. And actually, I've written a book, Healthcivity Journey, based on 12 pillars, which after many, many years reading and studying, and of course, experiencing myself, that sleep is the foundation because nothing actually is more important than that. So I am thinking about how fasting probably can enhance the quality of our sleep, or I don't know. I know I'm sure it can help, but maybe some people say that, okay, if I fast from, let's say, 4 p.m. to the next day, probably I'll get hungry, in the middle of the night. I don't know, maybe it has some negative effect on my sleep. So is there any study to show the relation between fasting and sleep, whether it can help the quality of sleep, or I don't know, maybe the opposite?
Yeah, I'm actually not entirely sure if there have been a ton of studies on fasting and sleep. I haven't really come across any major study there. There's plenty of like more anecdotal evidence. I can share my own personal experience with fasting and sleep.
Okay.
But anecdotally, fasting has been pretty good for sleep because it like your metabolic rhythms, as with fasting, are very tied to your circadian rhythms, right? That's why you're always told by sleep experts to try and like not eat a ton towards the end of the day because it does mess up your circadian signaling. If you have a lot of, glucose that are coming into the system, that's going to give you a sugar spike and more of that energy that's going to happen at the end of the day, or you're going to be prioritizing a lot of energy towards metabolism rather than, say, like, melatonin production or something like that. So fasting can be good for sleep, just kind of helping to reset those circadian rhythms, reset that metabolic pathway. My own experience with fasting was really interesting. And like I haven't had a problem sleeping with fasting except for one time where I was deciding to do a 60-hour fast. And I was doing that
Mhm.
for like experimental purposes, like taking my blood throughout a fasting time course to kind of see what happens in the human body. And what I experienced was the first day that I did it, it was fine. Like, typical 24-hour fast, something I've done before, didn't have a problem sleeping. The second day, I just got really, really scared that like I've never fasted for this long in my life before.
Mhm.
And like if I go
Mhm.
to sleep, I was just like convinced that I was going to die.
Right,
Like I,
exactly. Same feeling.
yeah, as,
Yeah.
as crazy as that would be. But like, that's what was going through my head. And I eventually fell asleep and everything was fine. I woke up the next day and I was like, wow, I'm immortal. But I think that there can be some like mental challenges that go
Yeah.
along with fasting that could, disrupt sleep because it's such a like it really is such a sensitive process. So if you're going in it with any kind of, fear or trepidation, it's not just going to be about what's happening biologically. It's also going to be about what's happening mentally.
Mhm. Right, exactly. Every time I say we are living in 21st century, but our brain does not belong to 21st century, right? It's actually for millions of years ago. So when we go to a very long fasting, that exactly I had the same experience. I went for 60 hours of fasting. And after 48 hours, my brain was just alarming me. Okay, if you sleep, probably you're gonna die, from any kinds of problems that probably will happen during the sleep. But our brain is just frightening us from dying, from not having, and doesn't the brain does not know that, okay, we are in a safe environment, right? And we have refrigerator, we have supermarket, we can eat, but this is something that we are doing that. So that's why, yeah, exactly, sometimes your brain, but I think it's the first time, and after that, then that would be easy. So I want to ask you a question, which for personally myself is very important. I try to do some exercise every day. Of course, I quit going to the gym and weightlifting because I really found that it is not improving my muscle as much as I really want or expect. So I now try some kinds of other exercises. So, but still, for people who, let's say, try to have some muscle, fasting, what is the connection between this? Because some people say, okay, if I go for 36 hours or 24, probably I'll lose muscle, and then it's really difficult to gain the whole muscle again. So what is the, let's say, relation between fasting and muscle, and is it good or really bad for that? I really am curious to know more
Yeah.
about it.
There are some studies out there looking at what happens during intermittent fasting and exercise. I haven't seen one that was, any longer than say 20 hours worth of fasting. Usually they're looking at the more of the 16/8 style intermittent fasting. And like you kind of get a mixed bag from the studies themselves. Like a lot of times you see that fasting is the same as caloric restriction in terms of actually inducing the weight loss, but a lot of times you see that fasting tends to help preserve lean muscle mass and actually kind of prioritize fat mass, especially during exercise. And that's more or less because your body is operating on this kind of like you use it or lose it principle, right?
Right.
So in any kind of caloric restricted state, and like including intermittent fasting, the best way to maintain muscle mass is going to be by actually going out there, doing exercising, prioritizing something like weight training, strength training, where you're actively engaging the muscles that you want to keep around, because that's going to send a signal to your body that says like, okay, like we're in an energy restricted state, right? But we're actively using these muscles, which means that we need them to, live and work and survive, right? So we're gonna prioritize keeping them around, and then instead like kind of utilize our excess fat pools as our energy source. Whereas in a caloric restricted state, when you're not exercising, your body actually prefers to pull energy from muscle cells because they're very energetically active, so they take a lot of energy to maintain versus fat mass, which is a lot lower threshold. So they'll pull from muscle because it helps to not only reduce overall metabolic rate, but then helps to preserve the more precious fat stores. So as with anything, like fasting can actually be very good for maintaining lean muscle mass and actually even growing muscle, but it all depends on what you're doing and how you're structuring your meal timing, your caloric
Mhm.
intake, all of that stuff. So
Yeah.
I've found personally that I haven't had a problem maintaining muscle, even doing, one meal a day. I haven't had a problem gaining muscle
Mhm.
doing one meal a day. And I think that the conception around that comes to the fact that you don't actually have to reduce calories when you're fasting, right? If you
Right.
can eat one meal a day and still be eating 2,000 calories, 2,500 calories, whatever it is, in your one meal or in your eating window, then from an energetics perspective, you're still going to be taking in enough calories, taking in enough nutrients and proteins to be able to maintain or even gain weight. But it's just going to, be at a different time scale throughout the day. So fasting
Right.
doesn't necessarily require that languish in muscle wasting or, even lose weight at all. It's just really a matter of nutrition.
Yeah. But probably it's a kind of challenge because, based on some studies, we cannot absorb more than 30, 40 grams of protein, at once. Probably you need like 2 hours minimum, the time between them so that our body. So imagine that if we need like 150 or 200 grams of protein, what do you think? Do you think that our body can really get the whole amount of that protein or no in just one, let's say, meal?
Yeah, I would say that the body is really interesting, in that, especially like again, like it's more of a personal thing for me. I've just been doing one meal a day for a while. I've been able to gain muscle myself and like, just eating in that very condensed window. But I've observed that my gastric like mobility is very slow, right? So like typically,
Mhm.
you'd have people who the resolution of the postprandial response is probably, 2 to 4 hours, right? For me,
Right.
I would say that that's a much longer time course. So I think that in response to eating at a lower time frame, your body kind of understands what the system is. It knows what to expect. It slows down gastric motility, so you kind of hold on to things for longer, so that you can get more nutrients out of it over a more prolonged period of time. But again, that's just
Fantastic.
my
Yeah.
total
Of
experience.
course, yeah, it's probably different from body to body or person to person. So let's now go to some questions about Mimi, all right? I want to again tell me or tell our audience about the story behind it, how everything started. And actually, it's a very simple idea. Everybody, when hears it, say, "Oh, really? Is there something like that?" And I say, "Yeah." But was there anybody, any company before you had such a thing or biohacking, let's say about fasting, or no, you haven't seen something before you? And how actually you came to this idea that we need something like that and it's possible actually?
Yeah, yeah. So in terms of, where the technology really came from, that was all coming out of my graduate research that I was doing at UC Davis. So I told that story before of going to Stanford, really kind of really falling in love with longevity and fasting research. And that was the thing that really catapulted me into researching fasting and trying to see what was actually going on in the human body to find a way to recreate those benefits effects. So I went to UC Davis, got my PhD in nutritional biochemistry, and spent the whole time essentially studying human fasting. And what we did for that study was we had 20 young people come in, 10 men, 10 women, to avoid a gender bias. And we had them fast for 36 hours, which is, typically what you would experience on a alternate day fasting regimen, which is where we've seen the best lifespan increase in terms of fasting. And we looked at their baseline state and their fasted state for these plasma functional metrics. And essentially, what we found was that the fasting made these already young, healthy people much more functionally optimal. So they were more anti-inflammatory, they were more antioxidant, they were more cardioprotective, they had much better metabolic markers. And that's really significant, being able to change around already young, healthy people into essentially super people just through one single nutritional intervention. You don't really see that a lot in nutrition research. So we really wanted to understand what was the difference between the baseline state and the fasting state that could be causing these beneficial effects. So we did what's called comprehensive metabolomics, basically looking at all of the small molecule components of the plasma. And what we found was that there was a unique set of metabolites that were upregulated during 36 hours of fasting that were only elevated during a fast. And when we screened through those molecules, we were able to find this synergistic combination of four of them that when we took them together and put them on human cells, we could recreate a lot of these beneficial effects of fasting that we had seen. So those same anti-inflammatory, antioxidant, cardioprotective effects. And then because this was also, a lifespan extension study as well to a certain degree, right? Trying to figure out the underlying longevity benefits of fasting. We took those four molecules and put them into a C. elegans lifespan extension model and saw that we could extend life by 96% just through supplementation with Mimeo. So basically, what the Mimeo formulation is and what it's doing is taking what your body naturally produces during a 36-hour fast and then giving it back to people as a supplement to kind of recreate that same like bioactive mix of metabolites, activate those same fasting pathways, but without actually having to fast.
That's amazing. So you talked about the components. So what are the active components in Mimeo, and how do they work to simulate the fasting status?
Yeah, absolutely. So yeah, the four metabolites that are in there, that's nicotinamide, spermidine, palmitoyl ethanolamide, and oleoyl ethanolamide. So nicotinamide is like probably pretty classic for most folks that are in the lifespan extension game or in the longevity space or even in the biohacking space. It's
Yeah.
a broad spectrum NAD precursor. And NAD is really important because that's basically one of the main ways that your cells sense nutrient status. So if you have higher NAD levels, that's essentially a cellular signal that you have lower energy levels. And then that ends up triggering a lot of post-translational modifications, a lot of epigenetic modifications that help activate these pro-longevity, pro-fasting kind of pathways that NAD cert access. Spermidine, really interesting molecule as well that's becoming really hot in the longevity space. That is mainly around its ability to activate autophagy, which is that cellular recycling and mechanism that we were talking about before. It's also been shown in a couple clinical studies to be able to help with cognitive decline and memory in older folks. So has this profound effect on cellular regeneration, but then also helping to enhance cognition and kind of slow cognitive decline. Palmitoyl ethanolamide, PEA, it's actually part of the endocannabinoid system, and its mechanism of action is to go to neurons and stimulate the secretion of anandamide. It's also a PPAR alpha activator and has been shown in a lot of clinical studies to have these very interesting effects, including, this really big reduction in inflammatory activity throughout the body, but specifically neuroinflammation, helps to kind of relieve pain as well. And it's more or less your body's kind of like rest, relax, and recover molecule, which is really interesting. Then the final one is oleoyl ethanolamide, OEA, which that's involved in the gut-brain axis and has been shown to help stimulate satiety and suppress appetite, both in animal models and in clinical studies. And then also there's some emerging evidence now that it can actually help to promote GLP-1 secretion from intestinal cells. So almost kind of like your body's natural Ozempic, but, promoting this beta oxidation, fat metabolism, like you would see in fasting, while also helping to suppress appetite. So it can actually help to make fasting easier if you're taking Mimeo as a fasting enhancer and not as a fasting mimetic.
Yeah. Actually, I used to take spermidine and NMN. So when I found out about Mimeo, I thought that, okay, I think this is, much more reasonable way actually to get these molecules. So even though you talked about that these molecules actually are made by our body, right? But still, some people are a little bit maybe curious about the safety of this, let's say, yeah, um, kind of supplement. So what do you say to people that they want to start using Mimeo? And of course, another question is, how should we use it, right? I mean, from about the timing, how many of them, and should we use it like, let's say, forever from now, or it's just a periodic like the usage?
Yeah, absolutely. So in terms of safety, yes, they are all natural molecules that your body, ordinarily produces during a 36-hour fast, and that's more or less how the technology works. I would say it's also important to note, like, you said you were taking NMN and spermidine before. Like we identified, and this was the really cool thing about the Mimeo formulation, that all of these molecules are kind of working together synergistically. So, like you could take NMN on its own or spermidine on its own, and it would activate, one element of this whole fasting bio program or another. Whereas these four together kind of are activating these complementary pathways that are helping to create effects that are greater than the sum of their parts. So when we did that lifespan analysis, we essentially saw that individually the molecules were good at extending lifespan, whether that was 5% extension or 10% or even up to 20% lifespan extension, but together could extend lifespan by 96%. So really helping to recreate some of that biological complexity that's happening during fasting, and turn, all these dials at once instead of one at a time. But in terms of safety, there haven't really ever been any significant adverse effects reported in any of the clinical studies that have been done with any of the individual molecules. There's over 100 clinical studies that have shown the safety and efficacy of these molecules individually. So we're really confident about the safety there. We've shown in our own pilot clinical study, kind of the absorption, digestion, and metabolism of the molecules themselves. So they kind of enter into the system after about 1 hour of ingestion, stay elevated for around 4 to 6 hours after that, and then disappear from circulation, whether that's because they were fully metabolized or just taken up into cells. So they come in, they get utilized, and they go away, within a 1 day period of time. So there's really not that same problem that you would have with, say, like a drug compound where you can kind of build up concentrations over time because they have a very long half-life. All of these molecules are
Mhm.
something that your body already inherently recognizes, knows how to, utilize, break down, and, continue on its merry way, essentially. So that's kind
Mhm.
of, the big safety disclaimer is that there seems to be no adverse effects. These are all just natural human metabolites, but they do have pretty powerful bioactivity. In terms of how we can use Mimeo, there's
Mhm.
a couple
Yeah.
different ways. One is as a fasting mimetic, right? We've shown in our pilot clinical study that when you take the Mimeo formulation in conjunction with a meal, you can actually still get a lot of these beneficial effects of fasting, those same anti-inflammatory, antioxidant, cardioprotective effects, even in the postprandial state. And it's also helping to avoid a lot of these negative effects of eating that can also come across in the postprandial state, such as dietary inflammation or that brain fog or these disruptions in metabolic homeostasis. You can also use Mimeo as a fasting enhancer as well, though, to kind of like help make fasting easier. A lot of people are doing the 16/8 style right now, which is great, but they kind of think that they're getting all of these great benefits of longer term fasting, like autophagy or,
Mhm.
or like these immune cell resets. But really, the major benefits of fasting aren't really going to start appearing until at least 24 hours of fasting when your body depletes its glycogen stores. So Mimeo can kind of help to jumpstart your fasting results, give you, the benefits of longer term fasting in a shorter fasting window, while also helping to make fasting easier because of these effects on appetite suppression and energy production and pain relief to a certain extent.
Yeah, fantastic. So here's my question actually, we're thinking about it. Imagine that we're taking, let's say, Mimeo, and it gives us the effect of like 36 hours. What if that after taking the Mimeo, we have another 36 hours of real fasting? Would we
Sure.
have like, let's say, 72 hours? Like, because, after like 72 hours, we have the growth hormone and, boosting the immune system and some other effects of fasting. So how does that work?
Right, sure. I would say that, it's not gonna, like stack exactly, right? You're not going to be able to, okay, I did a 36-hour fast and then took Mimeo, and now all of a sudden I'm at 72 hours of fasting. I would actually say that Mimeo is, it's designed to recreate what happens during a 36-hour fast. So that's kind of the time point that we're trying to recreate. So whether that's, taking it 1 hour after a meal, or whether that's, taking it at 20 hours of fasting. We're still just trying to get you to the point that you would experience during a 36-hour fast. So if you're already doing a 36-hour fast, you could use Mimeo to kind of make that process a little bit easier because of oleoethanolamide and its appetite suppression effect, or PEA and its like mood enhancement, energy enhancement effects. But it's not going to give you additional benefit if you're already going past that 36-hour mark. So usually what I tell people is like, it's great for daily use, especially if you're doing just the normal intermittent fasting. But if you are going to do like a multi-day fast, it's really going to provide benefit more towards the beginning processes if you want to jumpstart it, but less towards the end in terms of like, a 48-hour, 72-hour fast.
Right. So, I actually started like 2, 3 years ago, started fasting, intermittent fasting. And, I lost some weight and I felt better. It was great. So, beside the all benefits that you said Mimeo has, so, and my question is what is the effect on, let's say, the calorie absorption, or maybe even, I don't know, does it give us like the satiety feeling, or a little bit suppressed somehow? For craving something to eat. How does that work?
Yeah, absolutely. So Mimeo is not going to affect caloric absorption in any way. It can, however, affect some of the postprandial disturbances that happen in metabolic homeostasis. So, like we've seen that it can help to reduce postprandial inflammation. So whenever you're having a meal, you're taking a foreign substance into your body, right? And that's by nature just going to trigger an immune response. It's called postprandial inflammation, which is really, really common in the nutritional space. And that's, that happens to varying degrees, from anywhere from, I just had a whole pizza with like bacon and honey on top of it. That's going to cause like a big metabolic disruption, right? But even something like broccoli, right? And taking that in, that's going to cause at least some amount of transient postprandial inflammation. And Mimeo, thanks to the anti-inflammatory effects of all the molecules, can really help to prevent that. We've shown that it can help with increasing cholesterol efflux capacity after a meal, with stabilizing lipids after a meal, with helping to enhance cellular stress resistance after a meal, to really help, just keep you protected from some of this postprandial damage. And that's important over time because the typical Western diet kind of has built in these 3 meals a day plus snacks. So you're never really getting a full resolution of your metabolism throughout the day. You're kind of just constantly stacking all of these meals, all of this inflammation, all of this metabolic disturbances on top of each other. And that over time can lead to a state that's kind of like chronic inflammation or inflammaging, but is coming from the diet rather than, something else going wrong in the system over time. So Mimeo can really help to, prevent a lot of those negative effects on a daily basis. And then you asked about satiety as well.
Yeah.
So
Yeah.
one of the ways that Mimeo is helping with satiety is through, again, oleoethanolamide. And that's, again, involved in the gut-brain axis, where it's helping to stimulate satiety and promote fat-specific metabolism, while also it's been shown in clinical studies to help, regulate blood glucose levels, insulin levels, HbA1c levels, triglyceride, HDL, cholesterol levels, all these like big metabolic, cardiometabolic risk factors.
All right. So let me ask you a personal question. Do you fast anymore? Or
Oh
no,
yeah,
you're
no, no,
just,
I,
yeah,
I
really? Okay.
Oh yeah, I definitely still fast. Like I love Mimeo, but fasting just is, as a lifestyle, really works for me. So like my typical
Okay.
day is I'll get up, I'll have Mimeo and green tea, and then I will fast for the entire day. I'm
Oh.
doing 1 meal a day schedule. So I'll fast through the entire day. And that's really helpful for me just in terms of productivity. I find it's a lot more freeing to just know that I don't have to think about food. I don't really have to think about what my next meal is going to be. I can just kind of be in the productivity zone throughout the day. And then when that's done, just kind of switch that off and then go into this rest and relaxation mode, where I get this one
Mhm.
big, kind of indulgent meal at the end of the day.
Mhm.
It's kind of like my food reward. And
Mhm.
that just like really works for me. It helps me kind of compartmentalize my, busy startup CEO life from my, like, let's take a step back and just enjoy life. Like,
Yeah. I've started a project called Why Aging is a Disease and Why We Should Stop and Reverse It. So, in this project, I'm asking 100 scientists in the field of longevity, nutrition, some fields that are related to longevity, that from their perspective, why they think aging is a disease, or even though if they think it's not a disease. For example, Aubrey de Grey is not actually convinced that aging is a disease, or we can call it disease. But because it has a lot of consequences when we consider aging as a disease, and it has positive consequences. I would like to know your idea from your perspective, whether you can think of aging as a disease or should be considered as a disease. And I would like to have your idea in this project, because I already have talked to a lot of people and have their ideas, and finally it's going to be published as a book. So my goal from this project, is, I know that David Sinclair, as a very well-known person, is working on this and talking about all the things, but we need to just raise the awareness for normal people, and tell them, because a lot of people and scientists still, they say that, okay, aging is a natural process in life, so they just see it as it. And unfortunately, from my perspective, is the root of all evil, the root of all diseases. So we should do
Sure.
something about it. So please let me know, what do you think about this?
Yeah, I'm a bit on the fence of it as well. I'm not gonna lie. So I do think that aging is definitely a natural process, right? And I think of aging as akin to inflammation, right? Like inflammation is also a natural process. It's important for just like physiological functionality, right? You need an immune system to be able to fight off infections. However, it also has these deleterious effects, especially over time, right? It's one of those things that underlies a lot of disease progression. And basically, all major diseases have some kind of inflammatory component to them. And I think that aging is very similar in that, like, it's something that naturally happens in the body, but it's also something that happens in the body that over time leads to dysfunction and disease and most likely death if you're not, hit by a bus, right? So I would say that like aging is probably like to the best of my knowledge, not like a disease in and of itself, but something that's a huge contributor to all the other diseases that we concern ourselves with. So probably something that we should also be addressing as, a major factor and component to all other disease progression. Kind of like what we were saying before, right? Where young people by and large don't get sick because we have these, younger immune systems. We have these younger cells that have more protective mechanisms that haven't broken down over time. And if we can find ways to maintain that youthful functionality, then I think that you can tackle a lot of things that go wrong in all of these other disease states. So
Mhm.
I would say that, yeah, it's a symptom, it's a cause, it's something that we should be paying attention to, whether or not it's, a disease in the classic sense, or whether or not it's a disease in the FDA sense of like regulations, right? Can there ever really
Mhm.
be a, holistic human longevity study where we track, someone on an interventional basis throughout their entire life? Like, no, that's realistically just never going to happen.
Mhm.
But I think that if we start classifying aging as a disease in terms of getting more funding out there,
Mhm.
actually being able to tackle the problem in a regimented way, getting more universal biomarkers of aging that we can look at to establish, what intervention is and isn't working. That's something that just needs to happen because there's going to be more research. Everybody's really interested in this. We're on an upward trajectory, so things do need to change. We kind of need to reorient our thinking about aging.
Yeah, I'm thinking about the COVID, when we had it, the whole world came together with all the sources and money and scientists and everybody, right? Tried to find a solution, a vaccine for that, and spend maybe hundreds of billions of dollars on that. And they could do something that we used to do it in 10, 15 years, right? I mean, having a vaccine for a virus like this, it took longer, but because the whole world had the goal, what do you think if the whole world has the same decision and goal for aging? You know, contribute the whole resources from money, from science, countries come to this actually problem of aging. Don't you think that we will be like 10, 20, 30 years earlier we can kind of deal with the aging? What do you think?
Yeah, no, definitely. I would say that that's completely true. And you see this, just in the scientific realm in the US already, right? We have the NIH who essentially controls the purse strings of a lot of funding that happens and research that gets prioritized. That's why, with the current state of the NIA, all the money is basically going towards Alzheimer's research. So we get a lot of research on Alzheimer's and not a lot on these other, more interesting elements of aging or some of the more foundational stuff. So when money gets involved, right, wherever the money goes, science is going to follow because that's
Yeah.
just the way the system works. So if we get more people interested in aging, we get more funding to be able to look at it, we're going to be able to make these leaps and bounds forward because there's going to be the funding required to actually entice scientists to make those leaps and bounds.
Yeah. All right. So 8-hour time restricted eating linked to a
Hmm.
91% higher risk of cardiovascular death. This is something from American Heart Association. And it's been a lot of, controversial articles and talk and podcasts about this. So I would like to really know your idea. I don't know how much you have time actually to see these or
Yeah.
some
I
other.
mean, when someone comes after fasting that hard, it's difficult for me not to like know all about it and kind of get involved with it. And yeah, I would say just like pretty much off the bat that no one should really be taking this data seriously for a lot of reasons. And the first of which is number one, this is not a peer-reviewed published journal article. This is an abstract presentation, a poster presentation. So we don't have full access to the data set that they were using, the methodologies that they were using. What we do know is what the authors have actually like told us in interviews with the press. And from what they've actually said, this study was number one, it's a retrospective analysis of the NHANES survey set, which is essentially, a large repository of self-reported questionnaires from people all around the country about what their dietary habits are, and then kind of like, or like a lot of other survey questionnaires. And this one, we're more concerned about dietary things. But basically looking at the way that they collect this data is what's called 24-hour food recalls, which are like really notoriously ineffective at trying to figure out what people are actually eating. It doesn't ask any questions about what their normal eating patterns are. So let's say, someone came into this NHANES study and just happened to have a really stressful day at work. They had like childcare problems that they had to deal with, or maybe they were sick the day before they came in, they only ate one meal the previous day, right? Does that actually represent what they were doing for their entire lifestyle? Probably not, right? And that those 24-hour recalls don't actually assess, what your typical dietary patterns are. So that's like kind of what that study was doing. It was looking at this cohort of people that were tracked from, I think, if I'm remembering the dates correctly, 2003 to 2018, and looking
Great.
at, based on these 24-hour dietary recalls, whether or like, they kind of categorize them into time restricted eating or non-time restricted eating, and then looked at, what happened to their mortality over time. And they found that people who ate less than, like in a less than 8-hour window were associated with higher mortality from cardiovascular disease risk.
Mhm.
Then tried to say that that was because of intermittent fasting. And that's kind of where I have this big problem with it, is that when you think about it, the study didn't actually assess intermittent
Mhm.
fasting. And this is
Right.
really obvious because of that window of time, right? 2003 to 2018.
Mhm.
Fasting didn't really become popular until at least 2012, right? That was when the
Right.
first, like that BBC documentary
Mhm.
came out,
Yes.
that kind of like sparked the first 5-2 dietary regimen. And that's really when people got excited about fasting. There was like, a big resurgence in it. from 2012 kind of onward. But even like 2012, it wasn't that popular yet. It's really more in like the 2013, 2014, 2015 where you really see fasting become popular. Fasting became the most popular dietary trend in the US in 2019. So it's like an upward trajectory. But for the first, 12 years, or sorry, let's say 10 years, let's
Yeah.
10 to 10 years of that study, no one
Mhm.
was really fasting as like a
Mhm.
dietary intervention, right? No one was probably doing that as a conscious choice to like be part of a health trend. If they were eating one meal a day, it was probably because they had poor socioeconomic status. They were only able to eat one meal a day. That's all they could afford. They had a high stress job that has a lot of other,
Right.
complicating factors that go into their lifestyle, like high stress that could be contributing to their cardiovascular disease risk. So
Mhm.
like
Right.
there's just a ton of these factors that are going into the study that it's crazy to me that anybody even said that it was about like a time restricted eating pattern because they didn't establish
Mhm.
that at all within the study itself. Like it wasn't happening in society at the time. And yeah, there's just a really, really, really weird study that got a lot of attention and
Yeah.
that
Or maybe
because
we should wait for right to the study to be published because still it's just, as you said, just an abstract, right?
yeah, it is just an abstract right now. It's not published at all. We'll see if it actually does get
Mhm.
published.
Yeah.
But yeah, I would say that the main thing is regardless of what that study is like ends up showing, what the statistical analysis ends up looking like, it's still an observational study. So,
Mhm.
there's never going to be an element of causation to any of it, right? It's always going to be, okay, this particular thing, this particular data set that we were looking for is correlated with the
Mhm.
mortality rates of these
All right.
people, but it's not going to be causative. But when you actually look at the interventional studies that have done actual intermittent fasting, you see benefits to all of these cardiometabolic risk factors,
Right.
including LDL levels and glucose levels and insulin levels and HbA1c levels. So it like from the actual causative interventional clinical studies that we've done with fasting, you see all of these beneficial effects. And then an observational
Mhm.
study kind of connecting two things, in my opinion, erroneously from, data that is incomplete and not actually studying the thing that they're saying it's studying. That's
Right.
pretty egregious.
Okay, that's great. So, the last question is about the future of Mimeo. What do you see? I mean, or maybe I don't know if you have any plan for, is it only about a fasting or Mimeo has some other fields or areas of longevity that you want to biohack that also?
Yeah, yeah, great question. So Mimeo itself is a biomimetic human
Yeah.
health company. So
Mhm.
Mimeo is actually mimic and biology
Right.
smashed together. And so that's kind of getting at this underlying biomimetic approach that we want to take to science and longevity. So in the same way that, fasting is kind of this roadmap for us to finding this bio program of longevity that's already, contained within our evolutionary biology, there's a lot of other very interesting regenerative and beneficial states in the body that you can kind of run the same process with. So just like we recreated the 36-hour fast in this first product, you could do the same thing for exercise. You could do the same thing for cold exposure. You could do the same thing for sleep or meditation, identifying these, massive omic data sets that kind of help us decode what's happening in the human body during these interesting regenerative states, and then finding ways to recreate them so that we can get these
Mhm.
benefits on demand. That's really the future of Mimeo is, continuing to develop these clinically derived health and longevity molecules from human biology that we know will have an immediate context within human health because they're already a part of our physiological systems.
Thank you so much, Chris. It was really amazing. Thank you so much. And I know that you are kind of TikTok influencer. I've seen your
A little
amazing, funny,
bit.
really, it was amazing, your videos. But please let us know that where we can find more about you, especially about the Mimeo, any other social media website or something like this.
Yeah, absolutely. If you want to learn more about Mimeo, you can like read more about our story. You can check out our clinical discovery paper, learn more about the science at mimiohealth.com, Mimio health.com. If you want to see some more videos of me screaming about nutrition into my bathroom mirror, that's always fun on TikTok. I'm at that nutrition doctor, DR.
Okay. Fantastic. That's great. So we are going to put the links on the description. It was amazing talking to you, and we are looking forward to new products maybe from Mimeo soon. Thank you so much.
Yeah, absolutely. Thanks for having me. It was a great time.
Thank you.